All right, so if it's asking about oxidants or dehydration, just know that it is talking about these two different reactions. So we'll talk about dehydration reactions in a second, but oxidation reactions. So oxidation reactions are the addition of oxygen. Oxidation, more oxygens. And remember how there's 3 different kind of alcohols? Each kind of alcohol reacts with oxidizes different. So primary alcohol turns into an aldehyde and then a carboxylic acid. A secondary alcohol oxidizes into a ketone, and a tertiary alcohol has no reaction. Remember that. It does not oxidize readily. So now we have to find out what kind of alcohol this is. So butanol, so it's going to have 1, 2, 3, 4. This tells us that the alcohol is at 2, and there's also a methyl at 2. So we have alcohol at 2. It's also a methyl. So this tells us that this carbon is reacting with 1 carbon, 2 carbon, and remember, if there's no letters, a 3rd carbon. So this is a tertiary alcohol. Remember, tertiary alcohols do not oxidize. So this tells us that this one could not be oxidized. Okay. And now this is asking us, remember, to get a carboxylic acid, we need a primary alcohol. So we're looking for a primary alcohol here. So let's look at these. I think it's just this one. So butanol, remember 1, 2, 3, 4. It's telling us the 1 is telling us is the alcohol is over here. And then this carbon is only reacting with one other carbon, makes it primary. Remember, we're looking for a primary alcohol to change into that, so it has to be 1-butanol. Okay. Dehydration. So dehydration reactions, they're always going to yield an alkene. Every single one is going to give you an alkene. So just remember that. Dehydration produces an alkene. Okay? So this is an example of an alkene. We are getting rid of our alcohol. That's how you know if it's dehydration. In oxidization, the alcohol will still be there. But dehydration reaction, the alcohol will be gone. But with the dehydration reaction, there's 2 reactants. It is going to be heat. So heat is one of them. And then also a strong acid. That's what that is. So a strong acid has a high density of hydrogen ions. Remember that. So this is what is missing. That's what's supposed to be in that question mark right there. Okay. So if we were to dehydrate alcohol here, it's going to remove the alcohol from it. And remember, dehydration always yields an alkene. So we're looking for something that ends with -ene. So this is the only one that has that, so cyclopentene. So now we're looking for cyclohexene. So we're starting with the product, and we're trying to find the reactant. So remember, if we're starting with the product of the alkene, we're trying to go backwards and find the alcohol. So we're looking for cyclohexanol, the alcohol version, which is this one. Okay. So now we have dehydration of propanol, If we dehydrate propanol, we're getting rid of the alcohol. It's going to become propene because it always becomes an alkene. Okay. Now this one, we have this. So that is, we see that it's adding oxygen. So if it's adding oxygen, then this is an oxidization reaction. So because of that, we have to figure out if it's a primary, secondary, or tertiary alcohol. So if we look at it, this is the carbon, it's 1, 2. So this is a secondary alcohol. In secondary alcohols, what they'll do, they'll turn into a ketone, which means that the carbon that's connected to the alcohol will now be doubly bonded to an oxygen, and the hydrogen will disappear. So basically what this is telling us is to recreate this. So recreate it like that, except where the alcohol was is now going to be a doubly bonded oxygen like that. So same thing here, we're adding oxygen, so it's an oxidation reaction. Our carbon is connected to 1, 2 other carbons. So same thing here. This is a secondary alcohol that's going to turn into a ketone here. Or it's just going to doubly bond to the alcohol and the hydrogen will be removed. So we just got to build this again. Like that. And just doubly bond it like that. It's pretty simple. It's turning from this to that. Okay, a ketone, remember ketones produced by a secondary alcohol. So secondary alcohol. Oxidation produces what? If you go back a page, primary produces an aldehyde and then a carboxylic acid. So that. Okay. Tertiary alcohols cannot be oxidized. Remember that. Tertiary alcohols, if you add oxygen to them, nothing's going to happen. So remember, they cannot be oxidized. Same thing again. This is the same question. What is produced by secondary alcohol? It is a ketone. All right. Now, this is a dehydration reaction. Or is it? Wait, no, this is another. I forgot this one's stupid. Okay. This is another oxidation reaction. And this is only a primary reaction. So it's going to doubly bond with the alcohol again and turn into carbon. It's just going to be that since it's only singly bonded to one carbon, that's what the R means. The R is a carbon. That's the one carbon. Doubly bonded, so that means there's going to be a hydrogen up here. So that's what that means, kind of. Okay. Moving on, we are now working with things called ethers. Ether is an oxygen bond that is bonded to 2 carbons. So if you look here, oxygen bond bonded to 2 carbons. And how to name these is what you do is you figure out what this is. So this is an ethyl because there's 1 carbon, 2 carbon. Remember? Shoot, I thought I had it. Okay, so an ethane is 2 carbons. So eth but we're not using ane here because an ethane would have 6 carbons, and remember, or 6 hydrogens. It's only 5 here. If we remove a hydrogen but the carbons stay the same, it turns into an "-il", like that. So we have ethyl, and then this is also ethyl. So this is telling us that there's 2 ethyls. 2 ethyls, and then the end, this is an ether. So this is how you name ethers. You find the names of these. So you name this, and then you name this, and then you put the ether at the end. So this is an ethyl, this is an ethyl. It tells us there's 2 ethyls, diethyl. Next, okay, same thing. This is an ethyl here. So we know we have 1 ethyl. We could put the ether at the end. But this is, there's 1, 2, 3 carbons. 3 carbons tells us that it is a propane, or a propyl, like that. You see here, if you look here, CH2, CH2, CH3, CH2, CH2, CH3. So we're working with a propyl here. So, and then also this goes in alphabetical order. So we have ethyl, propyl, because E comes before P, and then the ether. So that's how you name those. Now this one, it's pretty much the same thing. You're just naming what this is. So this is a 1, 2, 3, 4, that's 5 carbons. 5 carbons are a pen. Remember til? In all of these ethers, we're using til, not like the tanes, pentane, or anything like that. We can put the ether at the end, but we have to remember, since this is in closed shape, it is cyclo. All enclosed shapes have cyclo before it. Cyclopentyl, and this is another ethyl. But we are going to put the ethyl after because C comes before E. So, like that. Now this one, you're going to count these. So we have 1, 2, 3, 4. 4 carbons makes this a butyl. And then we have 1, 2, 3, 4, 5, which makes this a pentyl ether. So this is pretty easy. You're just counting the carbons. So 1, 2, 3, 4. That makes it a butyl, a bute, and then ol. And then 1, 2, 3, 4, 5 is pentyl. Same thing here. We have cyclo. Remember, it's in closed shape. 1, 2, 3, 4, 5. Cyclopentyl. And then we only have 1, 2, which is another ethyl. So ethyl. Remember, C comes before E. And then we put the ether at the end, like that. Continuing on, now we're drawing it. So cyclopentyl, remember that's an enclosed shape with 5 sides. You could just get it from down here. And then it's like this. So you see we have the cyclopentyl here. We have the methyl right here. Remember the methyl is just that. And then this is the ether in the middle. So that's how you draw those. Continuing on, we have ethyl, methyl, ether. So our ethyl is 2 lines, remember? And then methyl is just 1 line. And then we put the O in the middle. So this is the ether right here. The methyl is this 1 line. The ethyl is these 2 lines. Okay, almost done. Now we have diethyl ether. So remember, ethyl is 2 lines. So we can do 1, 2 lines, 1, 2. And just make sure we put the O in the middle like that. So that's an ethyl, that's an ethyl. That gives us our diethyl, or 2 ethyls. Continuing on. Now this is, remember, an ether has an oxygen surrounded by carbons. So we know that this is an ether. Now we're looking for an ether. Number 1, this is an ether because there's an O here and O here. That can't be it. This is an alcohol. This is not an ether. Here, also not an ether. This is ether because it is an oxygen surrounded by 2 carbons. So we know that compound 3 is an ether. Final one, we're looking for isopropyl methyl ether. So this is saying that the ether is surrounded by an isopropyl, or 3 lines, and then methyl, or 1 line. So if you look here, it is connected to 1 methyl, but we have to remember if it's isopropyl, and isopropyl is like in a triangle shape. That's not a triangle shape, so it can't be 1. This one, that's connected to 2 isopropyls, so it can't be that one. 4, it's connected to a methyl, but then it's connected to a butyl, or 4 carbons. So this has to be it. So it's 1 methyl and then an isopropyl. So we know that it is compound 3. Okay, and that's how you do all of them. I love you so much. Let me know if you have any questions.